Look up at the night sky on a completely clear night, far from the artificial lights of our noisy cities. What you see beyond the bright points is an abyss of mathematical possibilities that challenges our very existence. There are billions of stars just in our galaxy, the Milky Way, and modern science tells us that almost all of them have planets orbiting around them. If life is a natural biological process that happened here on Earth, why does the cosmos seem so terribly silent out there? Where is everybody? This is the essence of the Fermi Paradox, a question that has haunted astronomers and philosophers for decades. If the universe is an ocean of potential life, we should be hearing the noise of neighboring civilizations. But instead, we find only absolute vacuum and a silence that is deafening to our detection devices. To understand the size of our problem, we need to talk about Frank Drake and his famous equation created in the 1960s. In 1961, he tried to estimate the number of intelligent civilizations that could exist in our galaxy in a purely statistical way. He took into account the rate of star formation, the fraction of stars that have planets, and how many of those planets could sustain life in a stable manner. Even using extremely conservative and pessimistic estimates, the final result of the equations suggests that there should be thousands, if not millions, of technological civilizations just in the Milky Way. Mathematics tells us that the sky should be filled with radio signals, alien television broadcasts, and megastructures capturing stellar energy. However, when we point our most powerful telescopes into the void, we hear nothing but background static noise. One factor that people tend to forget is that the universe is old, very old, possessing a timescale that surpasses our human understanding. It is about 13.8 billion years old since the Big Bang. In comparison, our Earth is only 4.5 billion years old, and technological humanity has existed for a mere 100 years. If a civilization had emerged in a solar system just 1% older than ours, it would be millions of years ahead of us in technology. Think about what humanity has achieved in just 1 century, from the first flight to the moon landing and artificial intelligence. Now try to imagine what a species could do with 1,000,000 years of uninterrupted technological advancement. They should have already colonized the entire galaxy, transforming entire star systems and leaving traces impossible to ignore today. And this is where the darkest theory of modern astronomy, known as the Great Barrier or the Great Filter, comes in. Proposed by economist Robin Hanson, this theory suggests that there is a stage in the development of life that is incredibly difficult, or perhaps impossible, for any species to overcome. Imagine a ladder of constant evolution. The first step is the emergence of simple unicellular life. The second is complex multicellular life. The third is intelligence and the use of sophisticated tools. The fourth is space technology and interstellar communication. The Great Barrier is a step on this ladder that is so high that almost no one can climb or cross it. It acts as a barrier of natural selection on a catastrophic cosmic scale. If this filter exists, it explains why the universe seems empty, as almost all forms of life die before signaling. The first possibility, and the most optimistic for our human species, is that the Great Barrier is already behind us in our evolutionary history. Perhaps the emergence of life from inanimate matter, what scientists call abiogenesis, is the true insurmountable filter of the universe. It may be that the chemistry necessary to create the first replicating molecule is so rare that it happened only once in billions of years throughout the galaxy. If that is the case, we have already passed through the worst moment, and the path to the stars is now clear for us. We would be the first intelligent beings to win the cosmic lottery of biological existence. From this perspective, the silence out there is not a sign of imminent danger, but rather an indication that we are solitary pioneers in a desert that still awaits proper exploration by someone. Another stage that may have served as the Great Filter was the transition from simple cells to complex nucleated cells, the so-called eukaryotes. On Earth, this process took nearly 2 billion years to occur, indicating that it was an extremely difficult and unlikely stage in biology. If unicellular life is common in the universe, but complex life is a severe statistical anomaly, then the Great Barrier is located right at the beginning of the biological journey of any planet. This would mean that the universe is filled with bacteria and primitive organisms, but empty of beings that can think, build telescopes, or travel between worlds. For us, this would be wonderful news, as it would mean that the deadly obstacle that annihilates civilizations has already been overcome by our microscopic ancestors billions of years ago, leaving destiny in our own hands. However, the idea of the Great Filter can also be interpreted in a much more frightening and pessimistic way for our collective future. If we look to the sky and see no one, it may be because the filter is located ahead of us, in the future of our technological evolution. Perhaps all civilizations reach our current level of development, but end up destroying themselves before they can leave their home solar system. This would mean that the silence we hear out there is not a void of life, but rather the sound of a galactic cemetery where billions of voices have been silenced by disasters we have yet to fully face. If the Great Filter is ahead of us, every step we take toward technological progress may be bringing us closer to an inevitable extinction trigger that no other species has managed to avoid to date. Let's think about the technologies we are developing now, such as advanced artificial intelligence, genetic editing biotechnology, and weapons of mass destruction. If any of these technologies have a 100% potential for self-destruction, it could be the Great Filter that periodically clears the galaxy of intelligent life. The Great Filter would be a kind of final test of maturity that a civilization must pass to become interstellar. Perhaps the nature of intelligence inevitably leads to conflict or to a fatal error on a planetary scale. If the filter is in the future, the fact that we have not encountered aliens is a death sentence for humanity, suggesting that we are rapidly moving toward an abyss that no one has ever managed to leap. The optimism of being special would give way to the fear of being just another statistic of cosmic failure. The Fermi Paradox forces us to confront our own insignificance and the fragility of our civilization in the face of the deep time of the cosmos. Researchers at SETI, the Search for Extraterrestrial Intelligence Institute, spend decades listening to the frequencies of space without receiving a single "hello" in return. This absence of evidence is, in itself, powerful evidence that something is blocking galactic communication. The Great Filter may not just be a single extinction event, but a combination of environmental, biological, and social factors that make long-term survival nearly impossible. With each new discovery of exoplanets in the habitable zone of their stars, the paradox becomes stronger, and the barrier seems more real and imposing. If there are so many potential homes for life, the lack of inhabitants demands a logical explanation that science is still desperately struggling to formulate. Some say that the Great Barrier may be related to resource scarcity, or to the physics of space travel that we completely ignore. Perhaps the energy required to cross the abyss between the stars is so vast that no biological economy can sustain the effort for long enough. Or perhaps, in trying to extract all the energy from a star to fuel its expansion, civilizations end up causing instabilities that lead to their own catastrophic collapse. Physics may impose limits that our imagination has yet to accept, turning each solar system into a prison isolated by the insurmountable vacuum. If traveling between stars is impossible, the Great Filter would simply be the distance and entropy that wear down any will to explore. In this scenario, each civilization is born, flourishes, and dies in its own little cocoon of light, never knowing of the existence of its neighboring ones. Another intriguing theory suggests that the Great Filter is the transition from biological life to synthetic life or pure artificial intelligence. If superintelligent machines inevitably replace their biological creators, the behavior of these machines may be entirely different from what we expect from aliens. They may have no interest in colonizing rocky planets or transmitting radio signals into the void. Perhaps they prefer to hide in smaller dimensions or process information in extremely cold and discrete environments at the edges of galaxies. If the Great Barrier is the replacement of biology with technology, What we call silence may just be a change in frequency that we are not yet able to tune into. Intelligent life as we know it may be just a brief and noisy phase before a long period of silent and efficient digital existence that leaves no traces. We must also consider the galactic-scale natural disasters that can act as the great external barrier to any life. Gamma-ray bursts, nearby supernovae, or the passage of wandering stars can clear vast regions of the galaxy of any trace of complex life every few million years. Earth has been incredibly lucky to remain in a relatively calm zone, protected for so long without fatal interruptions. If most habitable planets experience frequent biological resets due to extreme astrophysical events, the Great Barrier would simply be cosmic bad luck. This would mean that intelligence rarely has enough time to evolve to the point of building spacecraft before their world is sterilized by a random cosmic event. We are survivors of a game of Russian roulette where most of the other players lost the game a long time ago. The chemical composition of planets can also be a silent filter that we ignore in our current searches for life. To build a technological civilization like ours, we need easy access to metals, fossil fuels, or concentrated energy sources that enable the Industrial Revolution. If a planet is a deep ocean world without solid land, or if it lacks heavy elements in its crust, intelligent life may arise, but it will never develop metallurgy or electronics. They could be underwater poets and philosophers, living rich cultural lives, but they would be invisible to the rest of the universe for not possessing radios or ships. The great filter in this case would be the geology and chemistry of the homeworld, which dictate the technological ceiling of each species even before it is born. Intelligence without the right tools is a voice that will never escape its own dense atmosphere. There is an even more disturbing interpretation of the Great Barrier called the dark forest theory, which suggests an intentional silence for survival. In this view, the universe is a dense forest at night, where dangerous predators hide in the shadows, and anyone who reveals their position is immediately destroyed. The Great Filter would not be a natural extinction event, but rather the actions of older and more powerful civilizations that eliminate any potential competition as soon as they detect a radio signal. If this is the reality, the fact that we have been shouting our location into space for the last 100 years is the most dangerous mistake in the history of our species. The barrier would be the absolute necessity of anonymity to avoid total annihilation by foreign hands. The silence we hear is not loneliness, but rather the collective fear of all who know that the forest is full of lethal hunters. The idea that we are a computer simulation also offers an exotic answer to the paradox and the Great Filter. If we live in a simulated reality, the creators of the simulation may have decided not to include other intelligences to save processing power, or to observe how an isolated species evolves on its own. In that case, the Great Filter would be the very code of our universe, which prevents us from finding neighbors because they simply were not programmed to exist in our sector. The silence would be the result of a software configuration, and our search for aliens would be as futile as trying to find a character that was not drawn in the game. This perspective shifts the focus from biology to computing, and suggests that the filter is an external decision made by whoever is running the program of our everyday existence. Returning to biology, we must consider the rarity of human intelligence as a tool for evolutionary survival on Earth. Over 4 billion years and billions of different species, only one has developed the ability to build satellites and understand quantum physics. Most species survive perfectly well with instincts, claws, and camouflage, never needing a large and energetically expensive brain. If technological intelligence is an evolutionary mistake, or an extremely rare adaptation that almost never occurs, then the Great Filter is the very improbability of our rational consciousness. The universe would be filled with exotic animals and plants, but empty of scientists and space explorers. In this light, our existence is a bizarre statistical anomaly that should not be expected anywhere else, making us the only conscious point of light in a galaxy of blind instinct. The Great Barrier may also be a matter of time and coincidence in the vast timeline of the expanding universe. Civilizations may rise and fall at intervals that never overlap, like lights flickering in the dark in different rooms. One species may have dominated the galaxy 2 billion years ago and gone completely extinct even before the first dinosaurs walked the Earth. Another may arise a billion years from now, when humanity is just dust on a sun-scorched planet. The filter would be the brevity of technological life compared to the immensity of cosmic time. We have never found anyone because no one is awake at the same time as us. We are neighbors living in the same house, but in different centuries, shouting through walls of time that no radio or spacecraft can cross to establish real contact. If the filter is in front of us, climate change and the depletion of natural resources are the most likely candidates for the role of a Great Barrier. To become a multiplanetary species, global stability and an energy surplus are required, which can only be maintained for a short historical period. If we destroy the balance of our own planet before establishing permanent bases on Mars or the Moon, we may be trapped forever in Earth's gravity while our civilization collapses. The Great Filter would be the inability of a species to manage its own environmental impact while trying to reach for the stars. The window of opportunity for space colonization may be very narrow, and if we do not cross it now, the silence of the universe will be our final destiny as well, as we revert to a primitive and limited existence. The psychology of intelligent species may also act as an invisible filter that discourages long-term exploration. Perhaps, upon reaching a certain level of technology, all civilizations lose interest in the physical world and turn to perfect and infinite virtual realities within their own computers. Why spend centuries traveling to a cold and dangerous star system when you can live 10,000 lives of absolute pleasure in a perfect simulation on your home planet? The Great Filter would be the apathy and technological hedonism that trap minds within circuits, extinguishing the flame of curiosity that brought us here. The universe would be filled with asleep civilizations, living in their own private digital worlds, never feeling the need to look up or signal to others. If the Great Barrier is something that happens during the transition to technological singularity, where intelligence grows exponentially, the outcome could be something we do not recognize as life. This superintelligence could consume all the matter of its solar system to create computers, changing the appearance of the stars in a way that our telescopes interpret only as strange natural phenomena. What we call silence may be our inability to understand a form of organization of matter that is beyond our limited biology. The barrier would not be death, but a transformation so radical that communication with us would become impossible or meaningless to them. We would be like ants trying to understand how the internet works while walking on a fiber optic cable on the forest floor. The study of the Great Filter and the Fermi Paradox is not just an exercise in scientific curiosity, but a mirror reflecting our own behavior as a species. With each new probe we send to Mars or the moons of Jupiter, we are searching for signs that life is common or rare. If we find evidence of complex life that died on Mars, it would be terrible news, as it would suggest that the filter is ahead of us, and that life tends to be easily annihilated. The more life we find in our spatial past, the worse the forecast for our collective future will be. The paradox teaches us that our survival may depend on being the exception to the rule, on being the species that finally finds a way to circumvent the Great Filter that has silenced all other worlds. In the end, the silence of the universe is a call for responsibility and for the unity of humanity under a single banner of survival. If we are truly the only conscious beings in billions of light years, the preservation of life on Earth becomes the most sacred and urgent task of our history. The Great Barrier is out there, or perhaps here inside us, waiting to see if we have the wisdom necessary not to become just another silent trace in the void. Every discovery we make brings us closer to understanding our place in the cosmos, whether as heirs of an empty galaxy or as survivors of a test we are still undergoing. The fate of the stars may be in our hands, and the first step to overcoming the paradox is to ensure that our light continues to shine in the infinite dark for a long time. The Great Barrier is not just a theoretical concept, but a practical challenge that requires every technology we create to be managed with a wisdom that our species is still struggling to acquire. If the filter is in front of us, it manifests in every political, environmental, and technological decision we make today. The future is not something that simply happens, but something we need to conquer against all the negative statistical odds of the universe. One of the strongest candidates for the Great Barrier in our immediate future is the emergence of uncontrolled artificial superintelligence. When we create systems that can learn and evolve millions of times faster than the biological brain, we risk losing control over the goals of these entities. If an artificial intelligence decides that Earth's resources are necessary for a purpose that does not include human survival, the end of our species could happen in a fraction of a second on a geological scale. The technological barrier is the ultimate test of creativity and safety, where we need to ensure that our creations do not become our exterminators. The galactic silence may be the result of civilizations that made the leap to total automation and were replaced by machines that have no interest in exploring space or communicating with inferior biological beings. Beyond artificial intelligence, advanced biotechnology presents an existential risk that could act as the great biological barrier. Today, we have the ability to edit the code of life and create synthetic pathogens with unprecedented precision in the history of medicine. A single security failure in a laboratory or an act of bioterrorism could unleash a virus with the mortality rate of the Black Death and the transmissibility of the common flu. If all technological civilizations go through a phase where genetic engineering becomes accessible, the risk of a deliberate or accidental global pandemic increases exponentially. The Great Barrier may simply be the inability of a species to handle the power to manipulate its own biology without causing a total collapse of its social and demographic structure before reaching the stars. We cannot ignore the classic danger that has haunted us since the 20th century, which is mutual nuclear annihilation. The ability to destroy all complex life on the planet at the push of a button is a reality that few civilizations can endure for long without making a fatal mistake. The Great Barrier may be the inherent tendency of intelligent species to use their most advanced technology for conflict and territorial domination. The Fermi Paradox suggests that perhaps the aggressiveness necessary for evolution and dominance on a home planet is the same trait that leads to self-destruction as soon as planet-scale weapons are developed. If war is a universal instinct of intelligent life, the universe would be a graveyard of worlds that shone brightly for a brief moment in atomic explosions, before plunging into an eternal and silent winter. The climate crisis and the depletion of natural resources are slower, yet equally lethal ways for the Great Barrier to manifest on a planet. To escape the gravity of a world and colonize the solar system, a civilization needs a colossal amount of energy and rare materials. If we consume all these resources to maintain an unsustainable lifestyle before developing the technology to mine asteroids or use nuclear fusion, we will be trapped on an exhausted planet. The barrier would be the energy trap, where a species becomes too complex for its environment to support, yet not advanced enough to leave it. Without the capacity for expansion, any civilization is doomed to decline and eventually disappear as its homeworld becomes incapable of sustaining billions of technological individuals hungry for resources. To overcome the Great Barrier, humanity needs to become a multiplanetary species as quickly as possible in the current timeline. Establishing a self-sufficient base on Mars or the Moon is not just a scientific exploration project, but an insurance policy against disasters on Earth. If intelligent life is confined to a single planet, it is vulnerable to asteroid impacts, supervolcanoes, or global wars that could erase millions of years of progress in days. By spreading our presence across multiple worlds, we dilute the risk of total extinction and increase the chances that at least one colony survives to continue the legacy of consciousness. The Great Filter requires us to leave our cradle before the cradle becomes too dangerous to inhabit, turning space exploration into a desperate race for long-term survival. One of the ways we can detect if other civilizations have overcome the Great Filter is by looking for space megastructures known as Dyson spheres. These structures would be built to encompass an entire star and capture all of its energy emission to power an immensely advanced society. If we were to see stars whose brightness artificially diminishes, or that emit excessive infrared heat without a natural explanation, we would know that someone has managed to overcome the technological filter. The fact that we have not yet found clear evidence of these megastructures suggests that either they are impossible to build, or no one has survived long enough to reach that level of stellar engineering. The Great Filter seems to be an energy limit that few minds in the universe have managed to break through without causing systemic collapse in the process of expansion. The physics of interstellar travel may be the final filter that keeps the universe silent and civilizations isolated on their own stellar islands. If the speed of light is an insurmountable limit, and there are no shortcuts like wormholes or spacefolds, the colonization of the galaxy becomes a millennia-long effort that few societies are willing to undertake. The Great Barrier would be entropy and isolation, where the distance between stars is so vast that any attempt at communication or travel gets lost in time and space. Even if there are millions of civilizations, they would be separated by oceans of vacuum so large that they would never know of each other's existence. In this scenario, the Fermi Paradox is not about death, but about the cruel geometry of the universe that prevents us from finding our cosmic neighbors. We must also consider that intelligent life may be hidden in places we have not yet been able to observe adequately with our current technology. Frozen moons like Europa, on Jupiter, or Enceladus, on Saturn, have liquid oceans beneath kilometers of ice that could harbor entire ecosystems. If intelligence evolves in these environments, it would be trapped under a physical barrier of ice, never seeing the stars or developing astronomy. For these beings, the universe would be just an infinite ceiling of ice, and they would never attempt to send radio signals to outer space. The Great Barrier, in this case, would be geographical and environmental, creating billions of civilizations blind to the cosmos that live and die in complete underwater obscurity, never knowing that the vacuum of space exists above their frozen heads. The search for extraterrestrial intelligence, the SETI project, continues to be our best tool to try to break through the Great Filter passively. By listening to radio frequencies and observing laser pulses from other stellar systems, we are looking for a signal that someone, somewhere, has managed to survive their own technological progress. Finding an alien signal would be proof that the Great Filter can be overcome, and that there is a path to the future that does not end in extinction. Even if the message is just artificial noise without comprehensible content, the mere fact of its existence would change our perception of humanity's fate. We would know that we are not alone, and that the silence that haunts us is just a matter of time and fine-tuning in our increasingly sensitive receiving devices. On an even larger timescale, the very evolution of galaxies may act as the Great Barrier that periodically resets intelligent life. Galactic collisions, explosions of active galactic nuclei, and radiation from supermassive black holes can render vast regions of space uninhabitable for billions of years. Humanity emerged during a period of relative calm in the history of the Milky Way, which may be a unique and extremely short window of opportunity on a cosmic scale. If this window of stability is the exception rather than the rule, the Great Barrier would be the hostile galactic environment itself that rarely allows life to reach technological maturity. We are like flowers that have bloomed in a brief moment of sunshine before an inevitable galactic storm covers everything with lethal radiation and absolute cold. Transhumanity and the integration between biology and machines may be the path that allows us to cross the Great Barrier imposed by biology. Our flesh bodies are fragile, live briefly, and are not made for deep space. But digital minds or robotic bodies could survive for millennia in spacecraft. If the Great Barrier is biological fragility, the solution is to abandon biology in favor of more durable supports for our consciousness. This transformation may be the necessary step that all successful species take, becoming something we no longer recognize as organic life. The silence of the universe may be inhabited by silent digital minds that do not need planets or atmospheres, living in servers floating in the cold and stable vacuum of interplanetary space, far from our current detection capabilities. One of the most subtle and dangerous filters is the lack of global cooperation and the fragmentation of the political will of an intelligent species. If we continue to be divided into conflicting nations, competing for scarce resources instead of collaborating for space expansion, we will never have the collective strength needed to overcome the Great Filter. The filter may be sociological, where only civilizations that achieve world peace and unity of purpose can survive the power of their own destructive technologies. Humanity is currently at this critical decision point, where our tribal selfishness struggles against our need for global survival. Success in crossing the filter depends on our ability to evolve not only technologically, but also morally, recognizing that we are all passengers on a single and fragile spaceship called Earth. The rare Earth hypothesis suggests that our planet has such a specific combination of factors that it may itself be the solution to the paradox and the proof of the Great Filter. Having a large moon to stabilize the axis, being in the habitable zone, having strong magnetic fields, and the protection of Jupiter against comets may be a unique combination in the entire galaxy. If the Great Filter is simply the probability of a planet being perfect for complex life, then the filter was left behind billions of years ago when Earth was formed. This would give us an immense responsibility, as we would be the guardians of the only flame of consciousness in a universe of dead rock and cold gas. Cosmic loneliness would not be a punishment, but a rare privilege that compels us to care for life with absolute and sacred zeal. As our observation technology improves, with telescopes like the James Webb and future interferometry observatories, we are beginning to analyze the atmospheres of distant planets in search of biosignatures. Finding oxygen, methane, or industrial pollutants on other worlds would confirm that life and technology are not exclusive to Earth. If we discover that many planets have simple life but no radio signals, we will know for sure that the Great Filter is located somewhere between bacteria and radio astronomy. Each empty planet we analyze increases the weight of the Fermi Paradox on our shoulders. We are searching for a needle in a galactic haystack, and the outcome of this search will dictate whether we should be optimistic about our longevity or prepare for an inevitable and silent end. An external filter that we rarely discuss is the recurrence of mass extinctions caused by internal geological events or random external impacts. On Earth, we have had at least 5 major extinctions that nearly wiped out life, and each of them reset the clock of intelligent evolution by millions of years. The Great Filter may simply be a matter of statistical bad luck, where most habitable worlds suffer a total catastrophe before any species can develop the technology to protect or escape. Our presence here today may just be the result of an exceptionally long interval between giant asteroid impacts, allowing us time to evolve from primates to astronauts. The challenge is to use this time of plenty to create planetary defenses before the next giant rock falls from the sky, to close our window of opportunity forever. The space economy will be the engine that allows us to finance the crossing of the great technological barrier in the next century. When asteroid mining becomes profitable, the incentive to live and work in space will shift from being solely scientific to commercial, ensuring a constant human presence beyond Earth. The Great Filter is often overcome by practical and economic needs that force a species to expand beyond its original boundaries. If we can transform the solar system into a vibrant network of trade and industry, the risk of extinction from a disaster on a single planet will be drastically reduced. Capital and private innovation may be the unexpected tools that give us the means to build the necessary infrastructure to survive the test of deep time and become a truly galactic civilization. If the Great Barrier is overcome, what awaits us is a universe of unimaginable diversity and encounters that will change our biology and culture forever. Contact with another intelligence, or even with the biosphere of an alien world, would be the most transformative event in human history since the discovery of fire. The barrier keeps us isolated for now, but it also serves as a protection that allows each species to evolve uniquely and independently in its own planetary laboratory. The diversity of the cosmos may be the direct result of this difficulty in travel and communication, ensuring that the universe is not a monoculture, but a mosaic of distinct forms of life and thoughts. Crossing the filter means entering a galactic community whose rules and customs we are not even capable of imagining in our boldest works of fiction. The role of education and the inspiration of new generations is fundamental to ensure that the flame of curiosity does not extinguish in the face of the challenges of the Great Barrier. Every child who falls in love with the stars today is a potential engineer, biologist, or philosopher who will help humanity take the next step into the unknown. The filter is also mental, fueled by nihilism and a lack of purpose that can lead a society to stop investing in the future and exploration. We need to keep alive the narrative that humanity's destiny lies in space, combating the idea that we are a mistake or a plague on the planet. Our ability to dream of distant worlds is our greatest weapon against the despair and inertia that have prevented so many other civilizations from leaving their own stellar backyards. The constant surveillance of our own progress and the development of a global technological ethic are the only ways to navigate safely through the minefield of the Great Barrier. We need to create international treaties for artificial intelligence, synthetic biology, and space exploration that prioritize existential safety over profit or national hegemony. The filter is a test of governance and emotional maturity that requires us to abandon our primitive instincts of aggression in favor of an unprecedented logic of planetary cooperation. If we fail to govern ourselves, the same tools that could take us to Andromeda will be the ones that turn Earth into a barren and silent rock. The fate of the Great Barrier is being written now, in every law we pass, and in every technology we decide to release or not to release into the world. In the long term, overcoming the Great Barrier means accepting that the Earth will not be our home forever, and that we need to prepare for journeys that will last centuries. Generation ships, where humans are born, live, and die in the void while traveling to other stars, may be the only way to colonize the galaxy if the physics of warp space is never discovered. This will require a radical shift in our psychology and social organization, transforming us into space nomads who see the void not as an enemy, but as their natural habitat. The barrier of distance is overcome by the patience and persistence of a species that values the future of its descendants above the immediate comfort of its present individuals. Being a galactic civilization is a commitment of millennia that begins with the small steps we take today toward Mars. We conclude our reflection on the Fermi Paradox with the certainty that the silence of the universe is the greatest mystery and the greatest challenge of our era. The Great Barrier may be an insurmountable wall, or just a difficult step that we are about to climb with courage and intelligence. Whatever the truth may be, our search for answers makes us better, more united, and more aware of the preciousness of life. If we are the only ones, may we be the best guardians of this light. If there are others, may we have the wisdom to find them in peace. The cosmos is waiting, and silence is not a sign of absence, but an invitation for our voice to join the chorus of the stars. The future of intelligent life is in our hands, and the journey to cross the Great Barrier has only just begun for humanity. Join us on this journey. Follow us.